This is day 10 of Advent of Code 2025, and this challenge is called Factory. Just across the hall, find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shibu Inu. All the remains of the manual are some indicator light diagrams, button wiring schematics, and joltage requirements for each machine. So for example, this is what the manual looks like. The manual describes one machine per line. Each line contains a single indicator light diagram in the square brackets, one or more button wiring schematics in parentheses, and joltage requirements in curly braces. To start a machine, its indicator lights must match those shown in the diagram, where dot means off and hash means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. So, indicator light diagram, like dot hash hash dot, means that the machine has 4 indicator lights, which are initially off, and that the goal is to simultaneously configure the first light to be off, second light to be on, and the third to be on, and the fourth to be off. You can toggle the state of indicator lights by pushing any of the listed buttons. Each button lists which indicator lights it toggles, where 0 means the first light, 1 means the second, and so on. When you push a button, each listed indicator light either turns on if it was off, or turns off if it was on. You have to push each button an integer number of times. There's no such thing as half presses. Nor can you push a button negative number of times. So a button wiring schematic like 0, 3, 4 means that each time you push that button, first, fourth, and fifth indicator lights would all toggle between on and off. If the indicator lights were hash and then the rest were dots, pushing the button would change them to be first one off, and then these two on. Instead, because none of the machines are running, the joltage requirements are irrelevant and can be safely ignored. You can push each button as many times as you like. However, to save on time, you'll need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. So with this one, you want 1 and 2. So you could press the first 3 buttons once each, total of 3 button presses. You could press 1, 3 once, 2, 3 once, and 0, 1 twice, a total of 4 button presses. You could press all the buttons except 1, 3 once each, a total of 5 presses. However, the fewest button presses required is 2. One way to do this is by pressing the last 2 buttons, 0, 2, 0, 1, once each. The second machine can be configured with as few as 3 button presses. For this one, it needs 0, 1, 2, 3 to be on. So you could do 0, 4, 0, 1, 2, 3. You could do 0, 4, 0, 1, 2, then 1, 2, 3, 4, once each. Third machine has a total of 6 indicator lights that need to be configured correctly. 1, 2, 3, and 5. The fewest presses required to correctly configure it is 2. And this is done with 0, 3, 4, then 0, 1, 2, 4, 5, once each. So, the fewest button presses required to correctly configure the indicator lights on all the machines is 2, 3, 2, which is equal to 7 when you add them together. Analyze each machine's indicator light diagram and button wiring schematics. What is the fewest button presses required to correctly configure the indicator lights on all the machines? Okay, that sounds like a fairly difficult challenge to achieve, because for a lot of them there's no clear answer for it, like to automatically do it. You would have to do a button press, like there will be some guessing involved, because even though 0, 1, 2, 3, even though 3 is off, you could turn it on by pressing 3, 1, 3, 2, I think it was. And that makes it trickier because you kind of have to guess, out of curiosity, what is the actual input like. Okay, so it's much larger. Got, interesting, there's numbers which are like extremely large, which I guess could be, well, no, those are the joltages, which are probably for part 2. Okay, so I guess let's start off with getting the values. So you read the list, could split based on space. It starts with square bracket, then you know it's the input. It's parentheses, you know it's button, and then you split on space, comma for it. If it's curly brace, you have that. Okay, so I think we'll have 3 lists, one for this, one for this, one for this. What are these all called? So we will have variable lights is equal to list of, we'll do int array, and we'll do var buttons is equal to new list, and this will be a list of int arrays. First list is for the row, Second list is for each of these, and then the array is for the buttons themselves. And then, even though we're not using it, we'll create a joltages one. This can be also a list of ints. So let's go for each var line in input. So var line part is equal to line.split on the space. That splits there. For each var part in line part, if part dot starts with square brace, then we'll have a else if it starts with parentheses, then we'll have an else as well. Actually, instead of an int array, this should be a boolean array, so we're toggling it on and off. So we'll do var light is equal to new bool array, and it'll be the, actually we'll change this to light part, which can be equal to part dot substring, starting on 1, go to part dot length -1, as we're getting rid of the brackets from it. That's a string. So it'll be light part dot length, and then for each, so we'll do for I is equal to 0, I is less than length, I is light part dot length I plus plus, and then light index of I is equal to light I, light part I is equal to hash or dot, wait, we need to do true or false, that's right. Or is it just false? Okay, yeah, true or false. So if it's equal to hash, it's true, otherwise it's false. So we've got that part working. Now for here, it's parentheses, we have, what do they call it? It's buttons, so button part is equal to that, and then we will do button parts. It's not the best naming for this, but button part is equal to button parts equal to button part dot split on the comma, and then button array is equal to new int array with button parts dot length, and then for, let's grab this for loop, it's basically the same thing but with button parts, button array I is equal to button parts I, and it will be int.parse. So that should build up this section of it, but then we need to add button array to buttons dot add button array. And there's something wrong with you. Why is that? Because I need to, on this line, do var line buttons is equal to list. Just copy this, new of list int arrays, and we will be adding button array to line buttons, and then once we're out of this for loop, buttons dot add line buttons. And if it's neither of those, then it's the joltages, which, although not used, may as well just grab. So joltage part, and we can do joltage array with parts. Joltage array is equal to joltage part I. Well, apparently that's can't put character into int part, so we'll do toString and then that. And we don't need to add that, but we do need to do joltages dot add joltage array. And I forgot to do that for the initial light one, so we will do that here. Lights and light. So with this complete, I guess it's now on to actually running it. So we'll do var int I equals 0, I is less than, just do lights dot count I plus plus, and then we'll grab var light is equal to lights I, and we'll do the same thing for button with buttons, and actually we don't need joltage for part 1, so leave that. So we've now got our light, and then we have our buttons. Actually, I should run this, then console.write line. Let's do string.join. Let's verify that light is working. And let's do first index for button, see if that worked. So let's run that. Okay, so it's not working. What, line 43? So that failed here. Okay, let's take a look at what the button part is. See why that might fail. Okay, so I failed to, there's a parenthesis. I thought I would have, so button parts, did the substring. So let's take a look at part, and then let's take a look at button part, which I need to do after that. Okay, maybe I need to change this to -2. Okay, that seemed to have worked. Okay, let's get rid of these print lines now. See if we got the correct. Okay, now we're getting error here. That would be the same thing, -2. Still issue on line 54. What is this? Input string comma was on the correct input. Okay, so I forgot to split. That's why. Voltage part. Then we need to do voltage parts using button voltage part and do that for this. Okay, that seems to be working. So we have false, true, true, false. That is coming out larger than it should be. So where is? Okay, also need to do -2 there. False, true, true, false. Just correct. This one's false, 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 true, false. Correct. And it's false, true, 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 false, true. And that's correct there. We have 3 for the first one, 0, 2, 3 for that one, 0, 1, 2, 3 for there. Okay, so we've finally got setup for this done. So I think I'm reaching the point in this year's Abana code where I can't solve these problems myself and need additional help. So I ChatGPT'd to figure out how to do this because I don't think I've thought of the solution myself. And the solution it's come up with is to use BFS, where we're essentially, currently we're using lights as a Boolean array. It's basically saying instead of doing that, use it as like an integer. Then for the buttons, use like binary arithmetic to toggle on the bits on and off for that integer for the light. And then with that integer, I think it's saying record how many presses it took to get to that. So then you're finding the minimum one. Then when you eventually get to the actual result, you'll find the quickest way to do it. So we will go along with ChatGPT says. I looked through it and it seems to work, but haven't tested it. But first start off with actually creating the variable for total presses, and we'll add that to here. Next thing we do is turn this lights bool array into the integer, and it's calling that target mask equals 0. And what we do is for every bit for this mask, so bit is less than light.length bit plus, we are then essentially, if the light at that position is turned on, we then add that bit position, we turn that to a 1. So if light bit, or in other words, if it's true, we then go to our target mask, and apparently pipe equals 1 bit. I don't think I've ever seen this syntax in C#, but that is apparently what you can do, and apparently don't need the parentheses. So once this for loop is completed, then we should have the number of the integer decimal representation of our light, which we'll then use later on. So next thing to do is same thing, target mask, but now we're doing it for the buttons, so button masks. So var button masks is equal to new list of ints, and it will essentially be the same thing, but for the buttons. So let's do for each var button in button, which is here. We'll then do int mask is equal to 0, and then we go through the buttons in that. So int index in button, we then do mask pipe equals 1 index. So button is an int array out of here. We're then retrieving the value from within it and then toggling it on for the mask. And then we add that mask to the button masks. So we've now set up our integers, our masks for the binary representation of values. Now it's for the actual BFS. So we need to record the states of the lights. So when you've toggled a button so when you've got a blank light, toggle a button, turn a light on, record how many button presses it took to get to that. And then the shortest path to get to that one is saved. So we're going to first record the maximum amount of states, which is equal to 1. Then light, that would be light dot length, and then it's saying create the distribution as a new int with a maximum length of max states. And next what we'll do is create a queue. This will be for finding the shortest path to our desired outcome. So we've got queue. Actually, I missed a step. So it wants to record whether a path has actually been reached or not. So for, it's going to follow it exactly. So int s equals 0. S is less than max states. S plus plus. And then distribution s is equal to -1, where -1 represents it not having been visited yet. So we've done that. Got a queue. We then initialize the first index as being 0, meaning it has been visited, and I guess also taking 0 steps to get there. We'll do that. Then we queue.enqueue, and as we're using integers as our state management for the lights, we start off with int 0, meaning all the lights are off. And what we do now is just go through our queue. So queue.count is greater than 0. We retrieve our current state by doing queue.dequeue, and so we've got our state, and now what we need to do is get our current dist, which will be from dist state, and if state is equal to target mask, total presses, spelled presses wrong there, let me change that. This will plus equal the current dist, or the amount of steps it took to get to that light position. And we'd break, should have gone to the next one. But if you go past this, that means we're not there yet. And we can kind of do for each int button mask in button masks. And what we want to do now is create the next state, which is our state, and XOR flipping it with our button. So the reason for doing XOR for this is if the current state is 0 and the button is a 1, we want it to be toggled. But if it's a 1 and it's 0, you want it to stay as 1. So XOR is basically, you want them both to be different, which will make it true or 1. But if they're the same, it will switch. So if it's a 0 and it's a 0, then you're not pressing the button at all. But if you have a 1 and a 1, you're pressing the button, making it 0. So that's why XOR is used for this. And so we've XOR'd that. We now check to see if this position has been visited yet. So distribution next state. If this is equal to -1, we then want to set the next state so it's current distribution plus 1. So it takes one extra step, one extra button press to get to that state. And since we're now at that state, which is brand new, we add it to the queue. So after doing that, it should be finished now. So there's a little bit of a brute force method, but I guess it makes sense. So you start on the first everything blank, go through every single button press. So you have it, you press a button, got a new state, add it to the queue. Next button, press it, add it to the queue, so on. And then you go through the queue, going through that one. Press a button. If it's a brand new state, add to the queue. If it already exists, don't do anything, which you can tell that's the case with this. If it's -1, it hasn't been visited yet. The only way it could be not -1 is if it's already been visited, but if you're at the point where you go back to that state, you've already done multiple button presses to get there. So you don't want to add that to the queue either, because you've already got that state in the queue with less button presses. So with this method, you will eventually get to the final state, and it'll be the least amount of button presses to do so. So let's run this and see what result we get for this test, which should be 7, which we got. We will grab the test input, place that into here, and run it. And we got 447, which is correct. And we'll now go on to part 2. All of the machines are starting to come online. Now, it's time to worry about the joltage requirements. Each machine needs to be configured to exactly the specified joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the joltage levels. Ignore the indicator light diagrams. The machines each have a set of numeric counters, tracking its joltage levels. 1 counter per joltage requirement. The counters are all initially set to 0. So, joltage requirements like 3, 5, 4, 7 means that the machine has 4 counters which are initially 0, that the goal is to simultaneously configure the first counter to be 3, the second to be 5, third to be 4, and the fourth to be 7. The button wiring schematics are still relevant. In this new Joltage configuration mode, each button now indicates which counters it affects, where 0 means the first counter, 1 means the second counter, and so on. When you push a button, each listed counter is increased by 1. So, a button wiring schematic like 1, 3 means that each time you push that button, the second and fourth counters would increase by 1. If the current Joltage levels were 0, 1, 2, 3, pushing the button would change them to 0, 2, 2, 4. That would be making the first one go up, and then the third one go up there. You can push each button as many times as you like. However, your finger is getting sore from all the button pushing, so you will need to determine the fewest total presses required to correctly configure each machine's Joltage level counters to match the specified Joltage requirements. So with this one again, configuring the first machine's counter requires a minimum of 10 button presses. One way to do this is press 3 once, 1, 3 3 times, 2, 3 3 times, 0, 2 once, and 0, 1 twice. Configuring the second machine's counters requires a minimum of 12 button presses. One way to do this is by pressing 0, 2, 3, 4 twice, 2, 3, 5 times, and 0, 1, 2, 5 times. Configuring the third machine's counters requires a minimum of 11 button presses. One way to do this is by pressing 0, 1, 2, 3, 4 5 times, 0, 1, 2, 4, 5 5 times, and 1, 2 once. So the fewest button presses required to correctly configure the Joltage level would be 33. Analyze each machine's Joltage requirements and button wiring schematics. Okay, interesting. So it's different from the first one. So the first one was like binary arithmetic, but because of the nature of this, where it's actual numbers, it probably won't be the case. So let's go back to here, and we will copy, probably copy all of this. Go part 2 here, print out total presses. So we're at this point. Can't remember if I actually did this, but we'll first start off with int. What variable did we use here? Okay, we just used I. So that was for lights. We can use Joltage. So int I equals 0. I is less than Joltages dot count I plus plus. And I don't think I actually tried printing out Joltages to make sure it worked. Might be wrong, but it's been a while now since I was at that point. So it will do string join on Joltages I. And let's see what it prints out. That does not seem to be correct. Okay, where would I have gone wrong with that? So let's go back to here, console.writeLine, and let's take a look at Joltage part, and then Joltage part.length. Ah, that's why. I should have split first, and then use Joltage parts for this. That should have fixed it, I think. That looks correct. Let's just remove that quickly. Okay, there we go. So for this one, we will need to use integers. Let's do that. I don't need you anymore. So we'll create int array and target, which will be Joltages I. So this is what we are aiming for, and we will retrieve our variable name to use for that before. Actually, I didn't have a variable there, but we'll just do Joltage buttons is equal to buttons I. And what we need to do is create a brand new int array, same length as target, and that needs to be all 0. So int. Actually, it might be easier if we, instead of starting as all 0 and then going up to our target, just set it as a target and then decrement down. So once it's just all 0, then we know we've succeeded. So we'll do, just name this remaining. That will be new int target.length. And then we'll just copy target to remaining. So we'll do read.copy from, source, so target to Joltage buttons, no, not Joltage, remaining. What do you need? Length. Target.length. Okay, I'm not gonna be able to figure this one out myself. So once again, ChatGPT. I was on the right track with this, but it's not really much. So the next thing we need to do is record the buttons themselves. So it's saying create an int array called coverage, which is the size of joltage buttons dot length or count. What a realistic count. And it's saying create a variable of max coverage. Initialize at 0. Then it wants us to iterate through all the buttons. So B is less than joltage button count. B++. And then inside it's saying coverage B should be equal to alright, I missed a step. Create a variable C, which is how many joltages this button affects. So we're creating an array which is for storing how many joltages this button affects. So within the button, it's got the different joltages, the index of the joltage will affect. So more items for a certain button, it's going to store that. So for this one, store 2. It stores as C. Then it wants if C is greater than max coverage is equal to C. So that is all the setup that needs to be done for now. Actually, it wants us int best is equal to int.max value. And now it's DFS depth first search. It wants us to create a function for that. DFS, I'm going to do that correctly. This takes int button index and then int presses so far. So I assume this function will be for, well, it's going to be recursively running. It will be for, okay, so I think this is a brute force method where kind of just pressing all buttons, seeing what the state is, and maybe if the state's invalid, then skip that, and then something like that. Not sure. But first thing we do is if presses so far is greater than best, we return. So we're trying to find the quickest method. So we might get to a point where we get to the target, but we're way worse than the best. Int sum remain is equal to 0. I'm not sure what this is for. For int I equal to 0, I is less than target.length I++, and if remaining 0 is less than 0, we return because it's a bad one. Otherwise, sum remain plus equals remaining I. Actually, a mistake I made was I did I up there, but this now needs to be K. I'll do K for that. So I'm still not 100% sure what's happening. Like I thought I understood, but not really. So once you're outside of here, if sum remain is equal to 0, then if pressed so far, actually I need to spell that correctly. If this is less than best, then best is equal to press so far, and then you're breaking from this function. Oh wait, no, not break, return. If it's not 0, this is if button index is button index. Oh, right here. If this is equal to joltage buttons.count, then we've run out of buttons, but joltage is still needed, so that means it's failed. So we just return. Let's see, int min or presses equal to sum remain plus max coverage minus 1 divided by max coverage. It's max coverage again. That is U. That is maximum button coverage. So now if pressed so far plus min, okay, I understand now, is greater than best, we return. So it's basically kind of looking at, in the current state of things, the minimum amount of button presses we can do. If that is greater than what we've already achieved, then we need to break out. And if that's not the case, then we need to continue. So var button is equal to joltage buttons button index. We then now figure out int max press is equal to int.max value. And for int idx is equal to 0, idx is less than button.length, idx plus. Just figuring out how many presses we can do of the button, I'm assuming. So counter index is equal to button idx, and if remaining counter index is less than max press, then max press is equal to remaining counter index. Basically just the amount of times you can press this button and it stays valid. So if you press it too many times, you'll go over, which is invalid. So with that done, we're now going to try press the button more times. So for int press count equal to 0, press count is less than or equal to max press, and press count plus plus. Okay, so I think this is the actual section where the buttons are actually getting pressed. Right, that confused me, the upper part here, but now I know that. So if press count greater than 0, or doing int idx again, which is probably just this, int counter index is equal to button idx, then remaining counter index minus equals press count. So it's going through all the joltages within the button, it's then decrementing it by the press count, and then we rerun DFS with button index plus 1 presses so far plus press count. The way this will work is when you first run it, you start on the first button. Based on all the stuff above, if it's a valid button, we press it inside of here. We then run DFS again. So in this instance, we are testing it where that button is only pressed once. Press it once, we then go on to the next button, and we do this. So with the one press button, it will go through, then it'll go to the next button, so on, until it reaches the end. If it was able to successfully reach the target, it would save the button press amount to the variable. Get back to here, we do this loop again, and we press it a second time, and go through the whole process again of, with the first button, 2 presses, and then tries subsequent. So that is how that is going. So if press count is greater than 0, it has the same loop again, which I don't understand, but I'll include it anyway just because it has it. I feel like this is wrong, but we will keep it just because it is there. So we now want to get outside of the function, and we want to run it with the first button and then no presses. And once that has ran, total presses plus equals best, and then it would go back to the very top and go to the next row. So let's run it on the test 1 to see what it produces. That looks like a max int 32, so it probably failed somewhere. Okay, the issue was this section is actually meant to be for undoing the previous button press. So what's meant to be is a plus equals. Let's see if that fixed it. 33, which is correct. So we'll switch to the real input and we will run it. And that gave us 447. That doesn't seem to be right. No, 447 was part 1. It is still running for part 2, which is not a good sign. Okay, so apparently the issue is right here, using 0 instead of k. So there we go. There was infinite loop with that. So let's rerun it. So that didn't actually fix it. Only going back and forth with ChatGPT, trying to figure out what a possible solution is. Something it did suggest is ordering the joltage buttons. So it starts with the largest one first, and then goes down to the shortest. So just comparing the lengths and then ordering by the length. Don't know if that's enough, but maybe it is. Okay, so after doing some further investigating, this code will not work at all. There's basically too many buttons to do a more brute force attempt like this, and everyone online is using an external library. So we will look at doing that. So the library everyone using is called Z3. So let's add that in. .NET add package Microsoft.z3, and then once that package is added, we do using Microsoft.z3. Okay, so with Z3, let's take a look at what we need to do next. So I think all of this remains the same. Then let's go to here. So for oh no, that's part 1. Go down to here. Got joltages, target joltages, and we'll create a int counter count is equal to target.length, and int button count is equal to joltages button count. And now we're creating a context. Creating a context using ctx equals new context. Then inside of here, optimize opt is equal to context. That should be ctx. Doing ctx.mk optimize. Let's see, what do you Not sure what it's doing, but anyway, create that. And we're creating an int x array, int expressions, and that's called x, which is equal to new int expressions, the length of button count. Then for int b equals 0, b is less than button count, b plus plus, and then xb is equal to converting to an int expression using the context.mkint const, then creating a string x underscore I underscore b, like that. Then opt.add ctx.mkg xb ctx.mkint 0. Okay, so I got no clue what any of that is. So we do that, and I may as well remove all the old stuff I had. We got a clean slate. We're then going to iterate over the counter count plus var terms is equal to new list arith expression. Yeah, there's no way I would have been able to figure any of this out, but yeah, so now we're going to be iterating over the button b plus and create an array of ints for button, which is going to be the first or the current button. Then bool effects is equal to false. So now we go for int k equals 0, k is less than button dot length. So we're going over all the joltages that this button would have an effect on. Now if button k is equal to r, effects is equal to true, break. And if effects terms dot add xb, why are you doing that xb? Why isn't x doesn't exist? Where was x done? All right, this is meant to be inside of here still. Okay, so xb is added to terms. I got no idea what any of this means. Now arith expression LHS, if terms.count is equal to 0, LHS is equal to ctx.mkint 0. Else if terms.count equals 1, LHS equals terms 0, else LHS equals ctx.mk add terms to array. Okay, yeah, but still have no clue what any of this means. I was hoping that as we went on, I'd be able to actually understand something, but no, I'm basically just copying, pasting, or just typing out ChatGPT without a clue as to what any of it means. Now opt add ctx int target r. So opt add, so optimize add context mk equals LHS, which is the arithmetic expression. It's adding the target int. Okay, so now go outside of this for loop, do another arith expression, total expr, if button count is equal to 1, total expression equal to x0, else total expression equals ctx.mk add x. I have no idea what this means, but sure. So opt dot minimize total expression, and if opt dot check does not equal satisfiable, where did that come from? Oh wait, for this it's saying that there's no solution, but there should be a solution, so you don't need to do that. Model equals opt dot model int best for machine is equal to 0, for int b is equal to 0, b less than button count, b plus int num val is equal to, converting to int num, model dot evaluate x b true, best for machine plus equals val dot int, then total presses plus equals best for machine. Okay, so that's apparently what you need to do for it. I'm very confused by this. So I've never heard of the Z3 library, so it's hard to say what it is. But sure. Let's try run it with the, actually don't, .NET Run, try it with the test data, see what it produces, and it gave 0. That is very cool. So according to ChatGPT, we did everything, but we need to actually call it. So right here, apparently we actually did need that if statement, which I removed. Nice, so model, and so we got model opt, if opt.check does not equal satisfiable, then we'll do console.writeLine, failed, smiley face, return. Let's see if that actually does anything now. Still gives 0. Okay, so we've got this. Oh, actually, this is meant to be underneath here, I think. Let's try again. Okay, that did work. So let's switch to actual input and run it. 18960. So grab that and try again. And that was correct. So we're definitely at the point where I can't do these challenges by myself, but I hope you enjoyed going along with the journey, me trying to figure this out. But there's no way to really figure this stuff out by yourself. You actually need to have prior knowledge. Because I've never heard of Z3 and I've got no idea what it does. So if you want to see me stumble along for the next 2 days, make sure to like and subscribe.